Welcome to Retina Imaging channel. In this video, we will be talking about basal laminar deposits and the double layer sign and how they are connected to each other.
So as we know, the external retina has three remarkable structures which are external limiting membrane, ellipsoid zone and myoid zone. The fourth hyperreflective band is RPE-Bruch's membrane complex. Now this RPE-Bruch membrane complex is constituted by RPE and the Bruch's membrane. The structure of the Bruch's membrane also includes part of the RPE. It has 5 layers starting from RPE basal lamina, inner collagenous layer, elastic layer, outer collagenous layer, and chorea capillaris, basal and lamina. So RPE Bruch's membrane is basically a complex of RPE, its basal lamina, and rest of the layers of the Bruch's membrane. So what happens in aging? In aging, there is deposition of lipid between RPE and its basal lamina, and between RPE basal lamina and rest of the layers of the Bruch's membrane. So the lipid which deposits between RPE and its basal lamina is called basal laminar deposit, and the lipid which gets accumulated or deposited between RPE basal lamina and rest of the layers of the Bruch's membrane is called basal linear deposit. In this video we are talking about the basal laminar deposit. So this illustration shows how basal laminar deposit develops over a period of time with aging. If we start from the left, we see that in the young age the RPE basal lamina is a part of the Bruch's membrane and there is no deposition between them. However, as age progresses, their greenish basal laminar deposit is getting accumulated between RPE and RPE basal lamina, and as it progresses further with aging, it becomes thickened. We can also see basal linear deposit or BLamD located beneath the RPE basal lamina, whereas the basal laminar deposit is located above the RPE basal lamina. So what is the characteristic of basal laminar deposit? It's basically a thickening of the RPE basal lamina and consists of typical basement membrane lipids. This histological picture shows that early basal laminar deposits are thin and patchy and discontinuous, which is shown by the yellow star in the left side of the image, where the late basal laminar deposit is thickened and it is multi-layered. So how does the basal laminar deposit affect the function of the outer retina, RPE and chorea capillaris? So what are the harmful effects? So as the basal laminar deposit thickens the basal lamina of RPE and it impedes the diffusion of nutrients from chorea capillaris to RPE, it also impedes the egress of pro-inflammatory lipids from RPE to Bruch's membrane. So it hampers the transport both ways of nutrients from chorea capillaris to RPE and of the pro-inflammatory lipids from RPE to Bruch's membrane. However, there are certain helpful effects also, like in case of RPE atrophy, the basal laminar deposit works as a scaffolding on which RPE cells can grow. It also restricts the sub-RPE type 1 choroidal neovascularization from reaching the outer retina. So how do we image the basal laminar deposit? So basal laminar deposit has something to do with the double layer sign. What we know is that double layer sign is nothing but separation of RPE from its basement membrane, or in other words, separation of RPE from the Bruch's membrane. So a double layer sign or DLS can have fluid, it can have neovascularization, it can also have thickened and mature basal laminar deposit, and there can be any combination of all of these. So this is a double layer sign where we see there is a gap between the RPE and its basement membrane, and it is hyporeflective. So mostly it contains fluid. This picture was taken in the case of CSR. The next is a double layer sign which is hyperreflective, and this case was harboring a type 1 choroidal neovascularization within the double layer sign. So how does a double layer sign look when it is harboring a thickened basal laminar deposit? So this picture shows an OCT as well as histopathological depiction. So there are green, yellow and red rectangles. The green area shows the normal, yellow rectangle shows the double layer sign, and red rectangle shows the shallow irregular RPE elevation or SIRE. The green rectangle shows that there is no gap between the RPE and its basement membrane or basal lamina, whereas the yellow rectangle shows in the inset below that there is a split between RPE and its basal lamina, and the histological section of the same eye shows that there has formed a basal laminar deposit in this double layer sign. The red rectangle shows here that beneath the SIRE there is a double layer sign, and this double layer sign has been formed because of type 1 neovascularization as well as a basal laminar deposit. A thin basal laminar deposit may not be visible on standard SD or SSOCT. However, it can be visible on geographic atrophy or RPE atrophy. So this is how basal laminar deposits are formed, and this is how they look. If you like this video, then do subscribe to our channel. Thank you very much.